Are we waiting for more people, or should we start?
We should get going. We made an announcement around the hall that people will come through as they can, but we have to move on.
Okay. So, welcome everybody. What we are going to demonstrate today is native coexistence between LTE and Wi-Fi in 5 gigahertz. When we say native coexistence, we mean this. We're actually using an actual Wi-Fi MAC for the media access part of using the 5 gigahertz spectrum. And then the data that we're transmitting is LTE data. And in media access, we mean channel selection, listen before talk, using all of the Wi-Fi means to do that, including preamble decoding, decoding the Wi-Fi messages for internal information that can help us make the right decisions, and using CTS messages for channel reservation to minimize the overhead and the collisions on the channel. The same way, the exact way Wi-Fi is doing that. From simulations and measurements that we did, we see that using the exact Wi-Fi map for that purpose gets us the best system throughput and the minimal latency. And this technology can actually be used on top of LTE-U or LAA to be compliant with these specs, but to get a better performance on top of that. We're running the demo on the 61765 evaluation board, and later on you'll be able to see it over here. And we're using the 61765 supports carrier aggregation of 2 carriers, 20 megahertz plus 20 megahertz. So we're using one carrier in a licensed band and the other carrier in 5 gigahertz. We're using a Wi-Fi device, a Broadcom Wi-Fi device that's controlled by the 61765 CPU. So we're not using the Wi-Fi device for transmitting, for data transmission and reception. We're just controlling that for its MAC part. And we've designed, or we're using the same platform. We're using this platform for over a year now. And the same platform can support LTE-U, LAA, and LW. It's the same hardware with different software. The setup is simple. The 61765 is using one carrier as the primary cell and the second carrier as the secondary cell. And we have a Linksys Wi-Fi router that we're using in the same band. We're using the native Wi-Fi coexistence technology for several functions. The first function that is running is secondary cell channel selection. And for that, we were using Wi-Fi beacon scanning, preamble and packet decoding. And we're also using the LTE capabilities for energy measurements and LTE sniffing. And using all of that information, we're taking the decisions on which channel to select. So you'll see that later on a bigger screen, but the fact that we're actually using a Wi-Fi MAC gives us the entire breadth of information that a Wi-Fi access point has when it comes to select the channel. So we have, as an LTE-U or LAA small cell, we actually have access to the same level of information. We're also using that for listen before talk and for channel reservation. So there's this cycle here of Wi-Fi using the channel while the small cell is listening or doing the LBT listening before talk. Then, once we've we're deciding to start transmitting LTE data, we're transmitting a channel CTS message to reserve the channel for the length, for the time that we'll be using the channel. And Wi-Fi access points that are coexisting in the same channel actually see our small cell as a Wi-Fi access point because we're using the same language as Wi-Fi does. And this cycle goes on and on. And in the demo you will see the performance that we get when we turn LBT off and when we turn it on. So with that, we'll just switch screens and I'll hand the microphone to Dave.
Hi everyone. So as Ilan showed before and as he mentioned, so I have here a setup with the BCM61765 and the Wi-Fi, the 4630 as well in this board. And I have here a native regular Wi-Fi router, a Linksys router. And in this setup, basically what we'll show is the native coexistence. So I have here a Samsung UE mobile connected to the Wi-Fi router. And currently I send data with iPerf application of about, you can see it here, of about 100 megabit per second TCP data to the UE. So currently I'm sending only on the primary cell, which means that the current data rate is about 150 megabit per second on the primary cell, and we have the data on the Wi-Fi as I showed before. So basically the first step, as Ilan mentioned, is the channel selection. So we can see here in our debugging tool, it's called the Purview. So we can see the scan of the 5 gigahertz frequency. So we can see the Linksys router, which is transmitting to the Samsung UE on channel 36, 5.18 gig. And we can see that we have many empty channels in the 5 gigahertz bandwidth. And we have also one occupied by the Wi-Fi of the hotel. So of course, what we'll do here, we should pick an empty channel to transmit for the secondary cell. But in order to show the Wi-Fi coexistence, I basically choose for the secondary cell the same frequency as the Linksys router. So now I will turn on the secondary cell, but the LBT will be off. So we can see here basically that now I'm not listening to the Wi-Fi, I decide what to do myself. So the secondary cell transmit also in 150 megabit per second, but the Wi-Fi, we can see what happens to the Wi-Fi, it decreased almost to zero, to about 5 to 10 megabit per second. So if I'm not nice to the Wi-Fi decreases substantially, and I can send on the secondary cell. Now, but the total data rate, it's for LTE like 2 existing cells. Now we'll turn on the LBT. So when I turn on the LBT, the Wi-Fi got back to about 50 to 60 megabit per second. And we can see that the LTE on the secondary cell, I get about 70 megabit per second. So total for the LTE is 220 megabit per second, and the Wi-Fi is about 50 to 60 megabit per second, which means that I get a better spectral efficiency using the LBT rather than using Wi-Fi alone and only the primary cell. Instead of 250 megabit per second that I got together before, now I get about 270 to 280 megabit per second with the coexistence with the Wi-Fi in the secondary cell. So basically, as Ilan mentioned, we use here, in order to do the channel assessment, we do the preamble detection, and also we send the CTS to nowhere in order for the Wi-Fi to know that we're going to transmit for an on duration of X milliseconds. This is basically it.
So that's basically. So that's basically this is our platform for native coexistence with Wi-Fi, and subsets of that can be used according to the various specs that we'll see in the market in the coming time. Any questions?